Okay, this is problem number 3, and we're looking for the percent shaded. So percent shaded is the area of the square minus the area of the circle times 1/4, because only one out of those 4 regions are shaded in, and then the entire area is the area of that quarter sector. I'm going to put this length in as a length of 4, and then use that to start calculating some of these areas. Since that length is 4, that means that the area of the square is 16. That's also the diameter of the circle, so the radius of the circle is 2. So the area of the circle is 4 pi. Now on to the area of that sector. If this length is 4, that means also then that this length EH, which creates this 45, 45, 90 triangle, it's got to be a length of 4 root 2. So EH is equal to 4 root 2. So that means that the area of that quarter circle is 90 over 360, or 1/4 pi times the radius of 4 root 2 squared. And we can simplify this down by quite a bit. First of all, in the numerator, that's going to come out to 4 minus pi. And in the denominator, 4 squared is 16, root 2 squared is 2, 16 times 2 is 32, 32 times 1/4 is 8 pi. So there is an exact answer for us. And then if we find the approximate answer, that should come out to about 3.4%. This is problem number 4, and once again we're looking for the percent shaded. And the percent shaded in this one could be represented by the area of that trapezoid, and we know that those two sides are parallel, these two sides are not, so we know it's a trapezoid, and it's even going to be a right trapezoid, divided by the area of the really big triangle plus the 2 arc segments on the outside. I'm going to say that AB is equal to, let's use 6, AB equals 6, and then use everything from that. So then, since that length is 6, I know then that the entire diameter of the circle is equal to 12. I also know that any radius is equal to 6. So then I could draw in another segment from G to A. That length is also going to be 6. And because A is the center of the circle, because this triangle is inscribed, that means we have a 30, 60, 90 triangle. 6 is the hypotenuse. The short leg then is 3, and the long leg then is 3 root 3. Since this little length is 3 and the length of AB is equal to 6, that means that this length is equal to 3. And then in order to find the area of that trapezoid, we're going to look at triangle CBH. And it is a right triangle. We know that the length of CB must be equal to 12. And it's a 30, 60, 90 triangle. 12 is the long leg, so divide that by root 3. And then if we simplify that, we get that AB, or HB, is equal to 4 root 3. So then the area of that yellow shaded in trapezoid is going to be equal to the average of the bases. So we'll add those together. 3 root 3 plus 4 root 3 is 7 root 3. It has to be divided by 2 and then multiplied by the height of the trapezoid. So the area of that trapezoid is going to come out to 21 root 3 over 2. Now we'll start working on the areas of the denominators. First of all, we have the area of triangle, the area of the triangle CHI, that entire big triangle. So that area is equal to 1/2 the base. The entire base here is going to be 8 root 3. And the entire height is 12. So if we multiply these coefficients, 1/2 times 8 is 4. 4 times 12 is 48. So the area of that triangle is 48 root 3. Plus, then we need these 2 arc segments. We need to find the area of one and then double it. In order to find that, we're going to say that that area is equal to the entire sector minus the area of the triangle inside of it. So this entire sector, which I'll shade in green, is represented by the central angle. That's going to be 120 degrees. We know that because the inscribed angle is 60, so this has to be 120. Or we could have 3 equal angles of that same measurement. So the area of that sector is 120 over 360. That simplifies to 1/3 times pi times our radius of 6 squared minus the area of this pink triangle, and that's going to be 1/2 times 6 times 6 times the sine of 120. And we can simplify this a little bit for the area of the sector. 36 times 1/3 is 12 pi, that's the area of that sector. 6 squared is 36, 36 times 1/2 is 18. 18 times the sine of 120, that's the area of that little triangle on the inside. So then this part of our formula is 2 times 12 pi minus 18 sine of 120. So I'm looking to simplify this down a little bit. I noticed there's a fraction in the numerator, so I'll multiply the entire numerator and the entire denominator by 2. Leaves 21 root 3 over 96 root 3 plus, makes this become a 4. That 4 will distribute, making that a 48 pi. And this 4 will distribute to this as well, making that a negative 72 sine of 120. At this point I could put this into my calculator, or I could try to simplify it a little bit more if I like. And I notice that all of these coefficients could be divided by 3. So that'd give us a simpler answer of 7 root 3 over 32 root 3 plus 16 pi minus 24 times the sine of 120. And it looks like that's about as simplified as it can get. Plug that into your calculator, and that gives you an approximate answer of 14.3%.